Hey, what's up guys? My name is Cherno. Welcome to episode 75 of Game Programming. So, we're finally getting back to this. I'm in Germany right now, so my setup is a little bit different than it is at home. In fact, I'm on my laptop right now, so the screen resolution is lower, but even though I guess your video will still be scaled to 1920 by 1080, and also it's a little slower. So if you guys see an FPS drop, then that's just different hardware. Okay, so don't worry, I didn't change anything. Okay, so what we're going to do, and what we actually did last time was, if I remember, I think we did collision for projectiles, right? Let's just open up our game and see what we got here. Just double check that I am recording. Good, I am. Okay, so what we had over here was King Cherno here in all his glory, and I think I might actually change his sprite in the future to make it, well, match the setting a bit more. First of all, it looks like, I don't know, it looks really weird. And also scale him down a bit so that he's the same size as one tile perhaps, or something like that. Maybe like a bit more, maybe 1.5 times, because it just seems too big for the world. I mean, yeah. Okay, so yeah, I guess we did this last time. So the thing that I wanted to do now is essentially particles, right? So if we click and our sprite here, or our player here, he shoots, when the projectile hits a wall, it just disappears, and that's cool. But I think it'd be even cooler if instead of just disappearing, it would actually pretty much explode into like an array of particles. I think that'd be really cool, and I think it's a useful thing to teach you guys as well. So I'm just gonna go ahead and do it. So to do that, I didn't want to rush into it. I just wanted to pretty much split it into 2 episodes. The first episode, which is this one, will cover something that I wanted to do long ago but didn't, and that is a bit of screen class maintenance. And the second half of this episode is going to be about an essential particle class, right? So what a particle class entails, and basically the superclass of all other subclasses, which will be the actual particles, right? So basically laying the template, laying the foundation for particles. So that's what's going to happen today. My voice might be a little bit off. I am kind of sick, but I'm pretty much better now, so I thought I'd go ahead and make a video. So, screen class. Now, the deal with this is that we've got a bunch of render methods here. We've got render tile, we've got render projectile, and we've got render player. Yeah. What we haven't gone through and what we haven't really explained is, I might have explained this, I don't know, it's probably like half a year ago, how they actually work, but essentially why they do what they do, and how we can control the size of the pixel array that's being rendered, right? So what I want to do here, and actually I'm probably going to do that as the first render method here, so right under clear, I'm just going to make a new method called public void render sprite, yeah? And all this is going to be responsible for is just rendering a single sprite. That's it. It's just going to render a sprite. It doesn't matter what the size of the sprite is, it doesn't matter what color it is, it's going to render a sprite, that's all. And that'll be really awesome, as you will see in a minute. So X position, Y position, and the sprite that we want to render, and that's all we need, yeah? Okay, so first of all, as sorry, excuse me, as per usual, we need to render, we actually need to set our offsets, yeah? So last time, or well, not last time, but in every other render method, you see that we actually set our offset here by saying xp minus equals x offset, and yp minus equals y offset. We need to do the exact same thing here. And what that does, in case you guys don't know, is it just basically offsets our rendering code thing. So essentially what happens is we render the sprite to the portion of the map that we see currently. So in other words, if we want to render our sprite at a particular map coordinate, we obviously move the map around. That's when our player moves. The player doesn't really move, the map moves. And so if we want something to be kind of glued to the map, it's kind of like if you've done like visual effects or any kind of video, I guess, compositing, it's kind of like motion tracking footage, right? We need to glue our composite object here, which in this case, for example, could be a tile. Yeah, we need to make sure that it actually sticks to our land, right? So that when we move our map, the sprite moves with the map. So to do that, we just have to subtract its position from the suitable offsets. And remember, these offsets actually get set. If we go down here, offsets get set by the set offset method. If we right click on that, hit references and hit workspace, it'll actually search all references to that. And you can see that here in the level class down here, there's a render method which apparently calls this a thing. So if we double click on that, we can see that screen.setOffset gets called here. So what does happen? Every time we render our level, we need to render the offset of the view. Yeah? So if that makes sense, I'm glad, because it only makes half sense to me right now explaining it. But yeah, basically it just sets the offsets for the map so that whatever we render onto the map moves along with the map. Okay. So now that we've done that, because remember our sprites that we want to render, these sprites aren't going to float on the screen. This is a big one as well. This render sprite method. In fact, I might even add a boolean here called fixed. And fixed is kind of like if the position is fixed. So if the position is fixed, if we want to have it on fixed position, and I'll show you guys the difference as well, then we'll do this. If not, then we won't, okay? And you'll see the difference here. So what else do we want to do? We want to actually render the sprite. So we want to take the pixel array that we have from Sprite, from our sprite that we specify, and we want to kind of convert that into... we want not really convert it, we just want to set its value equal to the corresponding indexes of our displays array. So that makes like no sense. But what I'm saying is we've got an array here called pixels, and that is what we actually see on our screen. So we want to take the entire sprite and we want to put it into a specific location on our pixels array. Because remember, pixels array literally contains the pixels that we see on our screen when we launch the game. So the pixels in this game window are dictated, their colors are all dictated, and their positions are dictated by this one pixels array, right? So whatever we do to that pixels array, we'll basically see the visual result of that, right? So whatever we do to our pixels array will be reflected on the screen. So what we want to do is we want to take a portion of that pixels array, and instead of setting its color equal to a specific, I don't know, tile, if we put a sprite on top of that, we want to set the colors of those pixels equal to the colors of the sprite so that we see the sprite, okay? So we can do that by simply just copying and pasting, essentially. We're not copying and pasting, we're just assigning particular values of that pixel array to our sprite. So to do that, we need to go through every single pixel of that sprite and apply it to the other thing. So for y equals 0, as long as y is less than our sprite.width. What is this? Oh, okay, so apparently content assist is uninstalled. What? That is annoying. What? I'm gonna have to check that again, different computer. But we've got a, okay, we don't, but we will in a minute. So, size. Right, okay, well we do. And it's public, I believe. Yep, okay, cool. So, we've only allowed sprites to be square right now. Let's just change that. So public sprite int width, int height, and let's just say int color. Yeah, so that we can make a rectangle if we want. So I'll make private int width and height as well here. And if I scroll down here, I'll set this dot width equal to width, this dot height equal to height, and it's going to give us an error because we want to specify the final modifier. We'll just put size equal to width in the case of a rectangle, because we won't have to use it anyway. In fact, we'll put it equal to 0 because we shouldn't be using it, or even -1. Okay, and I think we can. How do we do it for the other one? We just set the color. Okay, cool. So set color to color. Okay, cool. And then we need a way to actually get this width and height. So over here, public int get width, return width, yeah, and public int get height, and that'll return height. Okay, so we've got getters and setters. Now the reason we do this is a big question that I get asked, and I might do a video where I just answer really common questions. So why make this private, right? We've made this private width, private height, but for some reason we've now made a public int called get width. You know, why don't we just keep this public and then just reference it by calling sprite.width? Why do we have to call sprite.getWidth? Now the reason we do that, the primary reason we do that is because once we create a sprite by calling a constructor here, we don't want to be able to change its size. Yeah? So by making this private, the only way we can actually access the value of the sprite's width or height is by calling getWidth, and you obviously can't use getWidth to assign, right? So to give you an example of that, in the past, we could, if we didn't keep that private, we could call sprite.width, for example, where sprite is any kind of sprite, yeah? Any kind of instance of sprite. We could call sprite.width, right? That's how we can set the width, yeah? By calling that. But what we can also do with this is we can actually set it equal to anything. That's correct, right? We can do that. Now, if it's private, we are forced to call sprite.getWidth. Now, you cannot do this, can you? Can't do that, okay? So that's the difference. That's why we do that. Because if we try and call sprite.width, it's going to tell us that it's not visible, which is what we want. So hopefully that explained why we use getters in this case. So these are called getters, essentially. Okay, cool. So size is -1. Okay, one other thing we should do here is, because we've set size equal to that, because we've created two new variables, width and height, we should set this dot width equal to size and this dot height equal to size. Okay, just to fix that. And we'll do the same for over here, just to make sure everything works correctly. Okay, awesome. So what we can do now is call sprite.getHeight, y++, back in our screen class. And finally, if we hit x here, do the same thing for the horizontal, sprite.getWidth, x, yeah. Now, what we're doing here is we're cycling through every single pixel of our sprite object. And what we need to do here, basically, is just set pixels at that particular location. Right now we're doing it without an offset. We will do it with an offset in a minute. But pixels x plus y times whatever the width is, which is just width in this case, equals to sprite.pixels. And again, there's no freaking auto completion for some reason, but I'll fix that for next episode. X plus y times sprite.getWidth. Yeah? And that will just work. Now, the problem here is, and this will work, in fact this will never fail, I don't think. The problem with this is that we'll just draw it in the top left corner, right? Because we're starting from 0 and we're going all the way to sprite.getHeight and getWidth. So it'll draw it in the top left corner. Now we don't want to do that. We want to draw them. We want to actually draw the sprite at these coordinates. So to do that, we can do what we've always done and just create a variable called xa, for example, for the x, and just say that xa is equal to x, right, which is our current pixel, and then we need to offset it by something, so xp. And then we do the same thing for y, which we can actually do over here to prevent, creating a lot of variables. Since this will only happen for values of y. If we put it into x as well, it'll create it every time it creates an x, and we don't need that. So y plus yp, and then we need to clip it, so if xa is less than 0 or xa is greater than or equal to width. So in other words, if we exceed the bounds of our screen, we don't want to draw it at all. That's what we need to specify. Height, continue, which will just skip this iteration of the loop and go to the next one without drawing pixels. And if it's good, then yeah, let's just do that. Now, you don't set this equal to xa or ya, right? Because we're only accessing, we just need to access the entirety of the pixels array for sprite, yeah? Whereas on the map, we need to draw it at a particular location. In our sprite's pixels, we need to get them from pixel 1 to from pixel 0, to all the way to get height and get width. Okay, sweet. So that seems to work. Well, we haven't tested it yet, but it will work. That's really cool. So that is going to be the basis of our particles, believe it or not. Now let's test it. And I think we're at like 14 minutes. Holy crap, that took a while. Okay, we're definitely not going to get onto the basis of the particle class. We'll do that in the next episode. But this was really important, and the reason is we're going to use this to draw particles, first of all. And second of all, this will allow us to draw any kind of sprite onto the screen. So yes, let's try it. So over here where we render our player, and again, this can be done anywhere, but just because render player conveniently has in fact, let's not do it here, since we can do it anywhere. Let's just do it in our main class, and I believe this has access to render, does it? Or screen? Yeah, it does. Okay, cool. Okay, so after we render everything, just before we actually set the pixels equal to what they need to be, let's call screen.render sprite. And I believe let's do it at 0, 0, and the actual sprite. Let's just make a new sprite here. So sprite equals new sprite, and we'll make it like 80 pixels by 80 pixels. And the color, is that it? Hang on. Let me just see what our parameters are, because there's an auto completion. Which means that I'm basically programming without an IDE here, which is annoying. Where's our sprite class? Come on, bro. Here it is. Okay. I must have closed it. Yeah, okay. That's it. In width, in height, and in color. So 80, 80, and color we'll just set to our favorite pink color, because that's how we roll. Okay, so sprite, and if it's fixed, let's just set it to false, just so you guys see what I mean. So for the last parameter, remember, if it's false, then it just ignores this offsetting. So if we launch our game right now, what we should see is will it crash first of all, which is weird. Null pointer exception. Oh, okay, we forgot to do one thing here, and that is create the pixel array. So pixels equals new int width times height. Wonder who caught on to that. Okay, so yeah, now we see well, it's not pink first of all, and the reason it's not pink is because I don't think we draw it at all if it's not a particular color. Okay, so let's ignore the stuff in the background. By the way, it's just recording my voice because I don't have two monitors obviously on my laptop, so I have to keep everything on one monitor. Okay, cool. So in fact, let's just bring this up. Oh, okay, it doesn't want to go away. Fine. Okay, sorry about that. Let's get back to game. Okie dokie. So, I think that's happened. I think it's rendering it in black because, let's just try. Oh, it's still doing that. Huh, that's weird. Okay, maybe it's, no, it's not. But what you can see here is that, we should probably fix this, shouldn't we? We should fix this, but I'm running out of time. Huh. Okay, let's just try something radically different. Okay, cool. So color's not really working. But what you can see is that if you actually look really closely, you can see that there's one blue pixel there. And that tells me something. That tells me that something's wrong in the thing. Well, obviously something's wrong. But if we go to sprite class, we can see that what actually happens is as we create a sprite with a width and height, we set the color equal to color. Now, what happens here is it goes from size times size. That's how many times that's the pixels that it has color to. Now, if we look at size for here, we actually set it to -1. So what it's doing is it's going, what's -1 times -1? It's equal to 1. So I is less than 1. So for once, it actually sets the pixel equal to color. Now, we don't want it to do that. What we want it to do is do it for width times height. So we can change this to width times height, and you can see that it works. So now that we've done this, one thing that we've actually enabled ourselves to do that we couldn't do before is sprites that are not uniform. So something like this. And that's really cool. Now, you guys might be like, why would I want this? And you do want this. And the reason you want this is because you can do some cool things with it. Like, well, for example, let's just set a sprite that's, let's just, I don't know, maybe like 20 and height. Okay, maybe a bit wider, so 40. And what we can do here is we can actually set width -40. And look at that, we're starting to look like we've got a bit of a run with a mad god kind of interface. So 80. That's probably too wide. And so what you can see here is that we've actually enabled ourselves to create graphics to the screen that move along with, that don't move, so that stay put onto our screen as if they're floating above the entire world, like you can see here. Now, clearly, this isn't 100% optimized right now because it is still trying to compute the data that's behind this, and we can fix that later. But for now, you can see why we would want that. Now, if we set this equal to true, what it's actually going to do is it's going to put this somewhere in the space. Now, I'm not sure where that location is, so let's just go ahead and see if we can find it. It should be somewhere in the top left. Okay, here it is. So yeah, you can see over here that this little pillar that we've created here is actually glued to our map. Yeah, which is awesome. It looks really cool because it looks like it's part of the map. So that's awesome. That's how that works. Okay. And that's what we can use it for. So, in the case of our particles, what we could do is something like this. So, we can make it probably maybe about 3 by 3 pixels, which is this big. It's probably a bit too big, maybe 2 by 2. Yeah, that looks good. Okay, so and let's just set this equal to like 50, so we can see it here. Here it is. And what you can do is, just so you guys can see it a bit clearer, I want to make it white. So it's right over here, our little particle here that's glued to the map. What I could do here is, you know, let's just render like, I don't know, I equals 0. Let's just render 100 of them, yeah? So if we render 100 of them, I haven't spoken English in a while, by the way, so luckily I can still remember it. Okay, so let's just set, do we have a random thing here? I don't think we do. No, we don't. Okay, that's alright. In fact, just for this, it's not going to matter. Yes, it is. Okay, random equals new random. Import that. Okay, so random.next, and let's just give it a variation of maybe about, maybe like 10. Okay, so something kind of like that. Now that looks ridiculous, I know, but what we can do with this is we can essentially have, as you can see, multiple particles as rendering the screen. You can see our FPS basically hasn't dropped either, which is awesome. But yeah, that's what we can do. We can just render a random amount of particles to the screen, and we can animate them as well. So that's how that's going to work. So I hope you enjoyed this episode of Game Programming, and this is the basis for our particles and how we're going to render them. So yeah, anyway, if you did, please hit the like button, and I'll see you guys very, very soon with episode 76, where we actually make particles. See you guys.